The lesson outcome for this video is, I can create and use a box and whisker plot. So what you see in front of you is exactly that. This is a box and whisker plot, and the box is this portion of the diagram, and the whiskers are this part. So this right here is the actual box and whisker plot. This down here is explaining what each of the important points in the box and whisker plot represent. So first of all, down here, this right here, this point, is the lowest value, or the minimum. Up here, that's the highest value, or the maximum, in our data set, and you're going to see an example of this on the next slide. Then we've got, I'm going to go to the median next here, because the median is something we've talked about. The median is the middle. So the value of the line, the vertical line that you see in the box, the value at that point right there is our median, or the middle number. And then we've got two other things that we want to know about, and that's lower quartile and upper quartile. And sometimes we notate these as Q1, Q2, and Q3, as you can see. So Q2 is the median, and Q1, the lower quartile, what this point here represents, or the data point at this value, is actually the median of the lower half of the data. So if you took the data only from the minimum to the median, and you found the middle of that, that is the median here, which is the lower quartile. And similarly, if we talk about the upper quartile, we're talking about this point here, data point here, that is the median of the upper portion of the data. So if you take the median to the maximum and you find the middle value, that's where the upper quartile, or Q3, is located. All right, so upper quartile, the lower quartile is in purple there. We've got our highest or maximum in blue, and our lowest value up there in red. Now there's also a couple other things on this screen that we're going to talk about sometimes, and that's the interquartile range, and that's if you take the Q3 value, the upper quartile, and you subtract the Q1 range, the lower quartile, you'll find the interquartile range. And then we know that the range of the entire set of data is whatever the maximum value is minus the minimum value. All right, let's take a look at an example. Okay, so let's take a look at this box and whisker plot right here. So you'll notice that the data for this box and whisker plot is about players' weights, and I don't know what type of team this is, perhaps a football team, and it looks like we have anywhere from, well, our scale, I should say, goes from 150 here, 200, 250, and 300. So now let's think for a minute about what these different boxes will uncover based on what you learned on the previous screen. So take a second and think, what does this red box here represent, right here, for this location on the box and whisker plot? Okay, hopefully you said that's the minimum, because it is. We had that in red on the previous screen. And then where's the maximum? Well, the maximum is up here. So the maximum is this highest value. Looks like the maximum value for the player's weight is over 300 pounds, and notice the minimum is somewhere between 150 and 200, so maybe 165 pounds right there. All right, so now what about this green one right here? What did the green represent on the box and whisker plot? Well, that is the median, the middle value. If we lined up all the players' weights from smallest to greatest, we would find the middle value there. And then the new two terms here, sorry, are, what do we call these? This was Q2, so this is Q1 and Q3, or in other words, the lower quartile here and the upper quartile here. So this box and whisker plot tells us some information about the players' weights. The median weight for this team is right between, looks like just shy of right between 200 and 250. So here's 225, so probably about 220 is the median weight of the players. And we said already the maximum is about maybe 320, 315, 165 maybe there for the minimum. And then our quartiles here are around just shy of 200 pounds and about, I don't know, 240 some pounds there. Now, I don't expect you to write down all these steps. I mean, you can if you are interested, but I'm going to run through these and refer back to this when we create our own stem and leaf plot on the next screen. So step 1, we have to place our data in order from least to greatest. Now, if you think about that, we know that we have to do that because one of our first jobs is to find the smallest and the largest and the median. And every time we find the median, we do in fact need to have our data from least to greatest. We're going to circle the minimal value, or the minimum, and the maximum value. And then we're going to circle the median. Now remember, just like when we did median in previous lessons, if two numbers are in the middle, we're going to average those two numbers together, add them, and divide by 2. All right, let's start there, and we'll refer back to this step 5 through 9 in a minute. So what we have here is some data, and this is data from the average temperatures from Seattle, Washington, San Antonio, Texas, and New York City in New York. I've already created the Seattle and San Antonio box and whisker plots based on their data, and now we are going to create New York's data, or box and whisker plot using its data. So again, step 1 is we need to order this from least to greatest before we get started so we can find the minimum, the maximum, and the median. So we see that 38 is the smallest value. I'm actually going to cross them off so I don't miss any. 40 is the next value. That makes some sense. Obviously January and February are probably the coldest months. And then we probably want to bop over here to December. Sure enough, 43 average temperature over there. So 43. Then we've got 50 for March, 54, 61, 65, 72, 76, 80, 84, and lastly 85. Double check that we have 12 data points since January through December. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we have all of them. All right, so to find the minimum, it's the lowest value. So there's our lowest value. I'm going to circle the minimum. I'm also going to circle the maximum value, which is 85, and the median value. So now the median, remember, we'll have to kind of go from the outside, and we're trying to go to find the inside, the middle value, all the way through here, and it's somewhere in between 61 and 65. Remember, we need to find the middle of these two values. So 61 plus 65 divided by 2. We have to find their average. Well, that's 126 divided by 2, which is 63. Some of you might have been able to figure that out without doing the math up in the corner like I did. 63 is our median. Now we are going to take a look at this list of steps on the previous screen again. Okay, notice that our next step is we are going to circle the median, or the middle number, of the lower half of the data. And again, if there's two middle numbers, we're going to average them. And then we're going to circle the median of the upper half of the data. All right, once we're done with that, the 5 numbers that we have circled are called the 5-number summary, and those are important for making our box and whisker plot. Okay, so now we're going to find our lower quartile. We are not going to include this median right here because that is a median, but it's not a data point. So we're going to use the 61 and the 38 and everything in between, and we're going to find the middle value. So not these two, not these two, here are the middle two, but we need to find the middle of those. So right here, we need to find our Q1, our lower quartile, pardon me. So we need to add 43 plus 50, which is 93, and divide by 2. And when we do that, we get 46.5 for our lower quartile, or Q1. And now we're going to do the same thing over here, not counting that median there, but these numbers here, here, and here. These are the middle two numbers, so we need to find the middle value between 76 and 80. Well, 76 to 80, if you count up by 2, you're going to get to 78, and you count 2 more and you get to 80. So we know that 78 is in the middle of 76 and 80. So we now have our 5-number summary, and we're going to put those points on our, using our scale right here. We're going to plot all those points. First, our minimum. Our minimum is 38, which is over here. And there's our minimum. And then we have, I'm going to put in our maximum next. Our maximum is up at 85, so here's 85 right here. Our median is 63. 63 is right about here. 46.5 is our our lower quartile. 46.5 is right in this region here. Again, notice 46.5 is right about here. This is 45, 46, 46 and a half. And then lastly, we have our upper quartile, which is 78, and 78 is right in this region here. All right, so now what we do is we use the minimum and the maximum first, and from there we draw our whiskers to the first and third quartile. So we can draw those lines here and here. Then I'm going to draw a vertical line through my first quartile, my second quartile, and my third quartile. And then I'm going to connect those, and there is our box and whisker plot. We will create box and whisker plots, and we also will analyze them, and that's going to be the key because we want to be able to get data from something that looks like this. So that'll be a big part of our practice as well. If you take a look at these, Seattle, San Antonio, and New York, you can tell immediately by looking at these box and whisker plots that San Antonio's weather is warmer on average. It has the highest low, it has the highest high, it has the highest median, so it is definitely warmer than both Seattle and New York. Now, New York has the biggest extreme weather values, so it's why the box and whisker plot is longer, whereas Seattle's is shorter, so their weather doesn't change a ton because it's all within a smaller range of values. So things like that is part of what we will discuss and practice in class.